you must use the law of cosines. All right, for this problem, you must use the law of cosines. All right, so we have the law of cosines. We use this already. We have a squared. All right, so we have a squared is equal to b squared plus c squared minus 2bc cosine of a. All right, so now what we can do is we can just substitute into this equation. All right, so what we have is we have a squared, trying to solve for that, is equal to b squared, that's 390 squared, plus c squared, that's 50 squared, minus 2 times 390 times c, which is 50, times the cosine of the 130 degrees that we found using our geometry. All right, so now we have a squared. Let's use our calculator. All right, so we have 390 squared. So it's a rather large number, 152,100 plus 2,500. Let's multiply all this out. Let's multiply all that out. The cosine of 130 is going to be negative. All right, so we have the cosine of 130. All right, that's negative. And then we multiply by 50. All right. Then we multiply by 50. And then we multiply by 390. And then we multiply by a negative 2. All right. All right, so we're going to end up with, when we multiplied all this out, I ended up with a positive 25068.71. All right, so now I'm going to add all this up. I'm going to add that to 2,500. I'm going to add that to 152,100. All right, and then I end up with a squared is equal to 179,668.7. I'm going to take the square root of that. And I end up with 423.873. Now, what does that have to do with anything? All right, we're really short on time. All right, so what this means is the plane was traveling 390. It experienced a 50-mile-an-hour gust of wind, and that increased the speed of the plane to 423.8 miles per hour. Let's move on to the last topic of the season, trigonometric special triangles that have special trigonometric ratios. All right, so here we go. Let's finish up on a good note. Let's talk about this new topic. Here we go. All right, so with this new topic, we're going to talk about 45, 45, 90 triangles and 30, 60, 90 triangles. These triangles always have certain ratios, no matter how large or small they are. If you have a 45, 45, 90 triangle, the ratios are 1, 1, radical 2. Those are the ratios of each of the sides. If you have a 30, 60, 90 triangle, the ratios are 1, radical 3, 2. No matter how large or small the triangle is. So what I want you to do is realize that anytime you have a 45, 45, 90 triangle, immediately label the triangle. 1 across the 45, across the other 45, label the 1, and then across from the 90, label radical 2 immediately, and get in the habit of regard. Notice how this triangle is turned around. This triangle here, it's still a 45, 45, 90 triangle, but it's turned around. I don't care how it's positioned. Across from the 45, label it 1. Across from the other 45, label it 1. Across from the 90, label it radical 2. I don't care how it's oriented. If you do that, you'll find that these problems are very easy. And the same thing holds true for the 30, 60, 90 triangle. Label the triangle. All right, across from the 60 is a radical 3. across from the 30 is 1, and across from the 90 is 2. Label the triangles immediately. I don't care how it's positioned. This triangle has been turned. If it's a 30, 60, 90 triangle, label across from that 30, label that radical 3. Across from the 30, across from the 60, label it radical 3. Across from the 30, label it 1. Across from the 90, label that 2. If you do that, you'll find these problems very, very easy. All right. So in addition to that, I want to show you one other thing that'll help you is you'll have to be proficient at working with radicals. Here, let's remind you how to work with radicals. Radical 3 times radical 3 is radical 9, and radical 9 is 3. All right, so radical 3 times radical 3 is a 3. Here, radical 2 times radical 2 is radical 4, which is 2. Hopefully you see the pattern. Radical 3 times radical 3 is 3. Radical 2 times radical 2 is 2. Hopefully you see the pattern there. Radical 9 times radical 9 is 9. Now here, radical 3 times radical 2 is radical 6. All right, so we're just reminding you of, you've got to be proficient working with radicals. You've got to be able to label the triangles properly. That's the first thing we talked about. And then you also have to be proficient with radicals. Let's keep going. All right, so here, radical 3 times radical 18 is radical 54. Radical 54 can be broken out into two radicals where one of them is perfect. It's radical 9 times 6 is 54. Radical 9 times radical 6 is radical 54. The radical 9 is 3. Final answer from 3 radical 18, you end up with 3 radical 6. Another way of simplifying radical 3 times radical 18 is to break out that radical 18. You end up with radical 3 times, you can break out that radical 18, radical 9, radical 2. Radical 9 is 3. Radical 9 is 3. So you end up with 3 times the radical 3 times the radical 2, which is a radical 6. You get radical 6 here, you get radical 6 there. That's just mastery level. Mastery level understanding. All right, so you've got to understand how to label these triangles. You also have to be proficient with how to work and simplify out these radicals. Let's simplify a couple more radicals that you could be presented with. All right, so let's say you have a quotient that has a radical in it. You could multiply that by 1. Radical 3 over radical 3. Multiplied by the radical that's in the denominator over itself. Multiplying by 1 doesn't change anything. So you simplify that down to 15 radical 3 over radical 3 times radical 3. We talked about that. That's radical 3 times radical 3 is 3. So now you end up with 15 over 3, which is 5. The final answer here is 5 radical 3. So you're gonna be asked to be able to simplify these radicals. Let's do one more before we move to a couple problems. All right, so let's say we have 3 over radical 2. They want you to get that radical out of the bottom. You got to multiply by 1. Over here, when the radical 3 was in the bottom, we multiplied by radical 3 over radical 3. Over here, when radical 2 was in the bottom, we're going to multiply by radical 2 over radical 2. That's going to get the radical out of your denominator. So what you end up with is 3 radical 2 over 2, and that's going to be your final answer. Notice how that radical is no longer in the denominator.